We had a question from Fiws, Fiws, I'm not sure, which says, for managed runtimes, what is the recommended approach to catch and handle errors? For example, through Sentry. Currently, we're only getting fiber failure when calling run promise, which does not give us the app stack trace, but some effect thing. My hack was a Sentry integration. So that's one question, and Fiws has a second question as well. But does that make sense to you? Are you aware of managed runtimes not giving stack traces?
I'm not sure if it's an issue that's like unique to managed runtime or if it might just be a thing with run promise, but like has this if I think that maybe like a way to handle this would be instead of using run promise, which would by default throw any errors that are not handled in the app, you could run promise exit and get like the full exit, which has the cause in it, and then you could squash the cause down to like its most important failure. If you wanted to do something like that, like I don't know which errors are attempting to be handled by Sentry. It looks here like maybe these are for defects. But that would be like a key question, because if it's defects that they want to send to Sentry, then yeah, you could just run promise exit and like squash the cause and send that to Sentry. I think that would work. What else could be done? I think that would be like the easiest way to take care of this. And I think this issue is not unique to managed runtime, but would also happen with just the default runtime. But yeah, if Fiws is in the chat, feel free to let us know if that does not answer the question.
Yeah. I think with questions like these that are a little more dependent on the exact structure. Oh, Philip. Philip is Fiws.
Philip. Yeah, I think that this is not an issue. Like, it's not really an issue with the runtime per se. It's a behavior of effect where any errors that you don't handle, like any expected errors that you don't handle, will be automatically elected by the runtime to a defect and thrown in a fiber failure, because that's in 3.0, that's how we raise errors. I think in 4.0 we're changing that a little bit to try to be more clear. But to basically be able to capture and inspect the error being returned by a runtime, I would say instead of run promise, which is going to by default like just throw, I would use run promise exit and then match on the exit itself. Check if the exit's a failure. If the exit is a failure, then you can inspect the cause. And there's lots of ways you can handle cause. In 3.0, mind going into a little more detail on what cause.squash actually does? Yeah, we can literally pull up the code and look at it. Hang on. But just to finish my thought, if you run the effect to a promise and get the full exit back, so run promise exit, then you can inspect the full result and do like whatever sort of pre-processing on the cause that you want. In 3.0, the cause data structure is not like the easiest to work with, and we know that. In 4.0, we've reworked the cause data structure to hopefully be a little bit easier to work with. There's still some refinements to do, but how bad is my hack that is on the screen? It's not a bad hack, but you could make this work a little bit better for you by running the promise to an exit. Run promise exit would probably be helpful here. Let me show cause.squash. It doesn't really do anything crazy.
Yeah, do you want to share your screen?
As soon as I find it, I will share my screen.
Gotcha.
Here we go. Okay. Where's my share button? I tried to find more info on 4.0, but I couldn't find any. Is there anything? You can follow the repository if you want. We have a list of to-dos we're working on. Renato, that's cause.squash for micro, not for the effect. I found it. I'm just gonna share my screen. Share screen. Share screen. The screen. Can you see my browser? I will make it bigger, but I just want to make sure you can see it. Okay. You're muted, but can you see my browser?
Yes. Yeah.
Cool. Okay, let's get rid of this. So, cause squash here, this method is what cause.squash is bound to. And basically the idea here is that we try to traverse the cause for you. Lots of background noise from someone, by the way. I think it's Kit. If you want to just mute Kit, sorry. What we try to do with cause.squash is surface the most relevant error to you that's within the cause that we can. So cause squash delegates to cause squash with, which is just a method that, or cause.squash with, which is just a method that allows you to look at any errors and sort of like decide what you want to, if you want to map expected errors into an unknown value. So anyways, cause squash, it just passes identity here, so we don't do any pre-processing on the expected errors. And so the first thing we do in cause.squash is we try to get expected errors, like the first expected error out of the cause. That's what failure option does. We can maybe take a look at this method as well in a second. Internal cause. I meant to open that in a new tab. So we try to get the first expected error out of the cause if we can. Because obviously the whole point of having the cause data structure is that it allows us to store both expected and unexpected failures. So the E, the generic parameter to cause the E, represents the expected errors in your application. Obviously, we can't type the unexpected errors because they're unexpected. But the idea here is we get the first expected error if it exists. We match on that option. If we got one, then we just return it. So cause.squash by default will return the first expected error in here if it can. If it can't find an expected error, then we check for unexpected errors, otherwise known as defects or exceptions or whatever you want to call them. And we attempt to get the first defect from the cause. If we find one, great, then we just return it. Otherwise, we then try to figure out if there's an interrupted error, like an interruption in the cause. Because cause can also store interruptions, like the interrupts that happen in the application. And if we were unable to find an expected error and we were unable to find a defect, then we try to find an interrupt and we return the interrupt. And then just so you guys can see what failure option does, cause.failure option searches through the cause and attempts to find the first expected error. So cause is like a abstract data type that has many different instructions inside of it, and one of them, or it's an abstract data type, and we basically try to find the first cause in here that is a failure. If we find one, then we return it. Otherwise, we just don't do anything. So this is a long-winded way of saying that cause.squash, the whole point of it is to try to squash down everything in the cause to like the most relevant error, if that makes sense. So yeah, getting back to the original question, I would say running the promise to an exit, checking if the exit's a failure, and then squashing the cause would probably be enough. And there's probably better ways of doing that, but I think that would be enough to get you started with Sentry. So. Good question, though.
Is it worth discussing the structure of cause at all? That could be somewhat interesting.
Maybe we can look at it. It's I don't want to like spend too much time on it because it's changing in 4.0. I mean, maybe we can even look at like the 4.0 version. In fact, small as well. But a cause. I'll open up the public module because the structure is better represented in there. So this description on the module is kind of, I think I wrote this. Did I write this? Maybe. We can kind of read through this, but basically this is saying that effect is polymorphic over type of E, which means that we can work with any error type that we want. But there's a lot of information that's not inside this E, because we've discussed before during these office hours that effects can fail for expected errors, which is represented in the E channel of the effect, but it can also fail for interruptions, meaning if the effect was interrupted, that's represented as a interrupt cause, which we'll look at in a second. And effects can also fail due to defects, which is not represented as a typed channel in the effect type, because there would be no way to type that. As a result of the fact that we can fail with many different other things, we need a place to store that information when an effect fails, and that's the whole point of the cause data type. It keeps track of expected errors that happen, defects, potentially stack trace information, Viber interrupt information, and so forth. And you can read through the rest of this, but that's basically the summary of what a cause does. Cause also has the ability to represent failures that happened when executing two concurrent operations in effect. So we'll look at this now, but the cause type, as I mentioned before, if we scroll past all of these errors, it's basically an abstract data type that's represented as a union of different things. We can have an empty cause, meaning there was no information for us to surface. We can have a fail cause, and this represents a cause that failed with some expected error of E. We can have a die cause, which is a cause that failed due to a defect. We can have an interrupt cause, which is a cause that failed due to some interruption, like an effect interrupt. And then we have these two types here, sequential and parallel. And what these are meant to allow us to represent are operations that failed either sequentially or during concurrent operations. So you could imagine, in effect, I'm just going to use an example. There are other examples of when sequential causes become relevant, but you could imagine that you have an uninterruptible effect or something similar that fails, and then some other operation executes after that, or has to execute after that, maybe a finalizer or something similar. In that case, maybe you'll end up with sequential failures that we want to package into the cause. So this type is meant to represent operation 1 executed, failed, then we had to run operation 2 to finish the computation or whatever, and that also failed. So you end up with multiple failures that need to be aggregated together. And then parallel is just when you have two operations executing concurrently, like a race or something like that. And we have to unify failures that happen in those cases. So you could search through the effect code base and see when these things become relevant. Like sequential. Let's just see if we can find a quick example of this. I don't know that I want to dive into the HTTP module, but here's one example, I guess. there's some work we do in here with, I guess, HTTP responses to figure out like what's going on. And in this case, there may be situations where if I guess whatever this stripped thing does fails, or if we get a stripped error, that's important to package up with also the defect that is represented by the response, I guess. So again, like there's situations where we need to represent sequential failures inside the cause. So that's the reason why that exists. And then the parallel branch here is again for concurrent operations. So yeah, I mean, that's really all a cause is. In 3.0, again, like this data type's not the easiest to work with all the time if you're not familiar with it. And even if you are familiar with it, it's not always the nicest to work with. So in 4.0, we refactored it a little bit, or I should say Tim worked on a new encoding for cause. Where are you, cause? So in 4.0, a cause can represent either a failure, similar to 3.0, a typed expected error that we can handle, a defect, a die, an unrecoverable thing that happened, your machine died, blah, 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 or an interrupt, so a fiber interruption. We were able to re-encode this as a data type that is essentially a thing that tracks an array of failures. And this failure E, where are we? Is the thing that represents these individual cases. So what we found through like auditing a lot of the code in 3.0 is that the use cases for these two branches and the empty branch, these two basically weren't necessary in JavaScript land. We can represent these perfectly fine with just an array of failures. And similarly, if the cause failures are encoded as an array, there's no need for the empty case. So we were able to reduce cause down to just these three cases by re-encoding it as an object that tracks an array of failures. And by doing this, like the type itself becomes much easier to work with because you can just access the list of failures and do stuff with it. Whereas with cause, because this is more of like an abstract syntax tree, it's like an AST of, sequential fail die. It's like more of an AST structure, which is, again, you have to have specialized methods to like operate on. Here, you're working with just like a plain array of failures. So it becomes much easier to work with to get information out of it and like figure out what's going on. Yeah, spent a lot of time talking about cause. Anybody have any questions related to cause?
Well, Fuse/Philippe had a second question. There's one in the chat too, which is, are properties hidden behind non-enumerable symbols in V3? Cause, pun intended, I have to do some nasty stringification in order to drill down deep into causes.
Benjamin, can you elaborate on what you mean by non-enumerable symbols? Are you talking about the type IDs that we attach to stuff, or is there other stuff that we have in cause that you have to access that you can't?
While he's typing, there's another question, which from Philippe, which is there a way to interrupt all fibers of a managed runtime? When the app terminates, we call dispose, but this does not interrupt the fibers. And then he links to an example. I'll paste that in the chat here if you want to open that up, Max. I would have thought that that's what dispose did. What else would it do besides, I guess, it would close its layer? Maybe it wouldn't interrupt the fibers?
Dispose doesn't interrupt fibers that are running by default. If dispose runs finalizers for the layer that it builds inside the managed runtime.
Mm-hmm. That makes sense. Is there a way to kill all of its all the fibers that it's run?
You would um, it depends on like what you what you mean by kill all the fibers, right? Like if you're disposing a managed runtime, this means you want to cleanly shut down all of these layers. But if you've got a thing running in here that's long running, you would need to somehow attach this to the scope of these layers if you want to dispose to shut it down, right? So what I mean by that is like, let's say we can rework this example a little bit. Oh, I see what you're saying. You want this sleep to be interrupted when the managed runtime is disposed. I'm trying to think of what the best way to do this is. In our case, we had a long-running platform command that we could not figure out how to stop. Well, one way is to one way would be to attach to basically fork that long-running work into a fiber that you can attach to the scope that's associated with the layer. Sorry, brain not firing on all cylinders this morning, so just might need a minute to come up with a good example for this.
Could you actually bump that font a little bit whilst brain?
No, I can't do that. Runtime.run dispose. Runtime.run dispose. Let me see. We have Steven joining us. Hello, Steven. I'm just opening Benjamin's question really quick.
Gotcha. Yeah, I tried to open the link. I didn't actually see anything. Or I wasn't sure. It looks like a Discord channel with a few things going on.
I'm unsure what channel post is going to affect cause. I'm digging into how cause nests failures and using effects equal drizzle. Middleware repo lives in the repo I'm working on. The only way I can reach the underlying Postgres error inside the SQL error is to JSON round trip the drizzle query error. Benjamin, have you tried squashing said cause to see what error you get out in that case? Like, I'm not sure I have time to like traverse this repro at the moment, but have you tried that? Also, I see we have Steven in here. I don't want to. Right? Do we have a Steven in here, or did I make that up? There's a Steven in the call, right?
Yes, I'm not sure if the audio is connected. Are you still thinking about the current example? Maybe we should sequentially and versus parallelly traverse our questions. Questiones.
Yeah, let's maybe. You're good.
Unless we need to come back to this. I mean, maybe this is worth exploring off. I guess not knowing how it worked, I would have assumed, I think similarly to Philippe, that dispose would interrupt. Yeah, could we make dispose interrupt true thing? That would be cool. Maybe there's just not support for this at the moment. I mean, obviously you could run, instead of running callback, you can like run fork and collect all of your fibers manually, but that wouldn't be particularly fun.
Hang on one second. I'm gonna try to answer Benjamin's question, and then we'll get back to this question. I did try squash, and it removes the error that I try to get, which is the Postgres error. You could also try cause.reduce, which allows, it's a way for you to traverse the AST of a cause. Let me just see really quick what you're trying to do. I'll pull it onto screen. Huh. 404. Yeah, maybe at the end of the day, I would like to create a robust database error class with a static method called match or something that would take an unknown input and do some cause pattern matching to return a new DB or instance with as much information as possible and wouldn't mind some test tracing.
Which question are you? I'm sorry, I'm just a little.
I'm reading a question in Discord, which I unfortunately can't pull over to the screen. But I guess I clicked the link in the question and it brought me to this page. But here's the full file. Maybe I can, like, I don't know, paste the file somewhere. Here. Copy this. Oh no. That file. So I guess this is the logic in question that is of interest. So if you have a cause that's a fail type, then you're stringifying the cause to inspect it. Okay, that's fine. Failure option. I'm sorry, I know this is small probably for everybody. Matching unknown, no error found. If there's an error. Yeah, I would suggest taking a look at cause.reduce for this particular case. You can see in our repo, maybe it's internal, reduce. So there are some examples of using cause.reduce in here. Or match might also be like a good one, because then in the sequential and parallel cases you could recurse depending on like what you find in here. I joined the office hours through my phone for the first. This was Steven. I joined the office hours through my phone for the first time, and I think it added me to the call rate. Completely unexpected. Sorry, huh? I blame Kit, Steven. I blame Kit 100%.
That's fair.
Yeah, you could try. So Benjamin, I would try either reducing over the cause, or in your case, maybe you want to match on it and then like recurse. Who's Kit? You mean Sam? Good point, Mattia. Yeah, this might allow you to traverse the cause a bit easier. In 4.0, it'll get easier again because we're not creating a tree, essentially, an AST. It's just going to be an array of like failures, so it's much easier to inspect like the things that came back when the program failed. Yeah. All right, let's move on from this question and see if we can figure out what is going on here. So you have a long operation that is running, and you want to be able to interrupt it. A better example here would even be this, because what we would want here is to be able to interrupt this if the program fails, or if the runtime is disposed. God, I wish my head was working better.
I mean, so when the runtime runs something, does it collect the running fibers inside of it, or? I mean, that's kind of what would determine the semantics, right?
It doesn't collect the running fibers inside of it. It does not.
And it doesn't automatically add it to some scope, their lifetimes to some scope, which is then closed. I mean, it just.
Let's take a look, because it's been a little while.
Yeah.
Of course, let's go to the internal file. Okay. Here we go. So when you call make, these are the things we do. We maybe have to create a new memo map if you didn't pass one in. If you recall, everybody, the memo map from our previous discussions, memo map is the thing that memoizes built services that come out of a layer. So if you pass one into the memo map, you can like use it outside as well. But we create one for you internally if we need to. Then we create a scope, which is just a regular scope. I don't know why we don't use unsafe make here. Then we have, this is the build fiber. This is the thing that, this is not fibers that we're tracking. This is the fiber that we use to build the layer. We have a runtime effect, which grabs the fiber that we're currently running in. If we don't have a build fiber, then we assign build fiber to the thing that's going to build this layer. Using the current scheduler. Yeah, I mean, this is basically the thing that's going to build this layer when you actually use it to run an effect, when you use the manage runtime to run an effect. So the whole point of like the managed runtime, the whole point of this is for you to build up a layer internally, like for us to build a layer of services up for you internally that'll allow you to run effects. But to Kit's point, the managed runtime does nothing to track fibers that it's executing. It's just a runtime. So disposing the managed runtime, all this is doing is closing the scope that's associated with the services in the managed runtime. It's not interrupting any fibers that it's currently executing. At least not that I could see. Let me just make sure. Internal runtime, unsafe run callback. Internal runtime.default runtime. Yeah, so I mean, if you have, like, if the program that you're running is not bound to this scope, like this case, right? In this case, we have this effect that's just holding the process open, right? We do nothing here. We're holding the process open here. So let's exemplify a layer dot scoped discard. So this layer is attached to the scope of the managed runtime. So when you call dispose on it, it closes the scope that's like registered here. But this thing is not associated with said scope. So this is just going to be like left open. We could consider, I'm not exactly even sure how this would all get wired up. Like I don't know how the interrupt signal would get propagated to the thing that we're executing. I can take it back and like talk with folks about this, but the best thing to do in case it like this example aside, right? I think this is more of like a general piece of advice. Whenever you have a long running effect, like a background fiber or something that could theoretically be a background fiber, whenever there's something like long running that's going to hold the process open, in our case, we're simulating that with an effect.never. I would suggest tying this to some sort of scope if it makes sense. And what I mean by if it makes sense, like here, obviously the runtime is detached from, like disposing of this runtime, we can see obviously this is not going to interrupt the thing that we're running. So in this case, it would be a good idea to like attach this to the like scope from this layer if possible. But I can see if it's possible, if I'm not sure if it's going to be possible, but I can see if we can do something like this.
What does a run callback return actually? And what is run callback? If you use run fork and run promise have not yet used run callback.
It allows you to get a callback like when the program is done with the exit, I think.
I see.
I think it's the exit.
And what does it return? A cancel. Ah, it returns a function. Is that something you can call to cancel it? To interrupt, rather?
Hang on, unexit. This is the thing that gives you the exit of the program. What else is in here? Run immediate. The scope to use to run this callback in. Whether or not refs should be updated. Where did you see a cancel? Oh,
the value returned by run callback is a cancel.
Yeah.
So,
yeah.
So what happens if we just call that after a second? Or immediately, I suppose.
No. Why? Okay.
Hey.
So I guess this would be the way to do it with the callback variant.
Yeah. If you do run fork, you get a fiber back, which you can call interrupt on. If you run promise, well, you might need to first return a fiber, and then it gives you an abort. Okay, you can give it an abort signal.
Yeah, so I guess this is one way. Then you could force interruption. Now, if you do this, if you call cancel, wait, expression is not right. If you do this, notice that the layer was not disposed properly in this case. This finalizer was not properly executed. So I would still suggest that you also dispose of your runtime, because again, when you use a managed runtime, like the whole point of a managed runtime is to allow you to write services in like a layer fashion, and only build them at the first time that you run an effect, right? So like if we were to run this twice, this program, it would only build this layer once. Internally, and then it would be a cached like set of services that we could reuse. That's the whole point of the managed runtime. But when you use a managed runtime, you're sort of opting out of the automatic like disposal of the scope when your program ends. So you need to make sure that you dispose somewhere, wherever it makes sense. Otherwise, your layers won't be properly cleaned up. I mean, if your server crashes, then like okay, whatever. But like, it's always a good idea to call dispose somewhere that it makes sense. And note that like dispose does return a promise. So like if you have somewhere you can run this that makes sense, that's always like a good idea. So like in Vercel, for example, in their what do you call it? Their API platform. I forget what it's even called, but like they actually have support for process process listeners now. So like processed it on SIGINT or SIGTERM. Like if you can register your dispose methods to these if you want. So I guess this would be one way to do it with run callback, but maybe we could also see if there's a way to force interruption when we dispose. But again, I don't think the scope that we dispose of here is tied at all to the fibers that we're running. So I'm not sure if it's possible. I'd have to look at like the code, but for now, this will get you the behavior you want.
Yeah, you could possibly wrap this, like if you always use run callback in your code base, just make a wrapper for your managed runtime that also exposes another run callback that collects all the cancels, and then have its dispose call both dispose in the managed runtime and call cancel on every collected cancel object. Yeah. Cancel type, whatever that is, callback.
Let's see. You can see here we actually got a sequential cause, a bunch of nested sequential stuff. But like this is why like working with cause is like in 3.0 is not the greatest, because you get these giant trees. So like understanding what actually happened by inspecting a cause can sometimes be quite difficult in 3.0. In 4.0, this would just be like an array of errors that happened. So anyway, hopefully that answers the question. That was a long discussion. I can figure out if like it's possible to support interruption from dispose, but my gut feeling is no, because I don't think we track the fibers that are running here. So anybody else have any questions? Unrelated question. How would you parse a schema AST? Looking to do something like generate a form from different types of inputs based on a struct of a schema's keys. You would literally just switch over the AST tags in a schema. Schemas expose in their AST. RJ, we will get to you in 1 second. But like if you have a schema, oops, I didn't mean to do that. So all schemas expose their AST as a property, and then you can just switch. Over all of the cases. So hopefully that answers your question, Leo. You can also look at examples inside schema where Julio does a lot of this. Just be aware that traversing the AST can be complex, but it's definitely very powerful. And yeah, you lose type information as well, because the AST is like the untyped side of the schema. So there's a scopes question from Adam. Let me open Discord 1 second. What is the difference between a closable scope and a scope? That is a fantastic question. And it's one that I can answer. Yes. Okay, here we go. Let's look at an example of a program which makes use of both a scope and a closable scope. So Adam, it's a great question, right? So take a look. So in effect, when you access, let's say that this program is going to be, right now it's not a scoped program. It doesn't have any scoped behavior. There's nothing that we're doing that requires a scope. But let's say we were to access the current scope, right? The second we try to do this, the program becomes a scoped program. It means the program now requires you to provide a scope when we run it, right? So if we were to program.pipe effect.run promise, this would not compile because we need a scope. And if we provide one, then we're good. Now this scope, if I enter down a few, this scope is not a closable scope. And the reason for this is because if you had the ability to manually close this scope, you could affect resources that were outside of the control of this effect. This scope is coming from outside this effect. It could be managed elsewhere. The lifetime of this scope is being managed somewhere else, right? We're accessing it and we're like using it for stuff. Maybe we extend this scope onto other effects that we're using. Like maybe we do this scope. Maybe we do scope.extend scope effect.add finalizer effect.log I was finalized, right? Let's forget the dual order for this. And we have to deal with this. But the point here is that this scope is not manually closable because the lifetime, like the control of this scope is being managed outside. If we were to be able to close this scope manually, like let's say I was able to do this, scope.close, right? Then when I try to close it again here, that's a double close of the scope, which makes no sense. We're saying that the lifetime of the scope is managed here in this effect.scoped, and this will provide a scope to this program. But if we close it here, then we're assuming control of said scope, and that just makes no sense. So when we have when we access a scope in a program, or we use methods that need a scope, the scope that is provided to said program, we know the lifetime is being managed somewhere else of that scope, where it's eventually going to be closed.
I just want to interject briefly because Enrico had a question that's very related, which is they're always confused when they should use scope. They've read a bunch of effect code like LSP and the VS Code extensions, and quote, I've never really understood the logic behind the choices very often. I get rid of all the scopes and everything works fine too without any change. I'm not sure if you mean explicitly using effect.scope and getting your hands on a scope object. I would agree with you unless you're doing some library implementation where you explicitly want the scope for reasons. You probably can just use the higher level methods like add finalizer or acquire release, and just either use something like layer.scoped, or in the test framework have the tests handle the scope for you, or use effect.scoped or something. But you probably won't grab a scope like Max is doing here on line 7 unless you really need it. Shouldn't show up too much in user land code. And if you're talking about use cases for scoping in general, yeah, also maybe not something you need if you're not opening up a bunch of resources. It definitely is not used in every program ever. One very simple use case that comes up all the time for me is if you're doing some testing of CLIs or whatever that operate on the file system. The file system service has a bunch of temp directory methods and temp file methods where you can create temporary directories and temporary files, and they have a scoped variant that will clean it up for you, which is very nice in test. So you can have a bunch of file systems created. You can use Git in there if you're testing some Git services or whatever, and it'll all be deleted and cleaned up for you at the end. Anyway, just wanted to address that. Oh.
Yeah, no, makes perfect sense. And Enrico, for your last point that Kit's highlighting here, sometimes in the 3.0, I've seen folks just use, instead of layer.effect, they just use layer.scoped because they want to, like, it's like a cover your you-know-what move. It's a CYA move. Just cover your bases. Because using layer.scoped, it's not harmful necessarily. It's like a way of you sort of cover your bases. In 4.0, if you notice, we'll just pull it up on the screen for a moment. In 4.0, you'll notice in the layer module, layer, there is no layer.scoped. There's a bunch of scoped in like the comments, but there is no layer.scoped. And the reason for this is that because layer.effect in 4.0 implicitly creates a scope for you. So the scoped variant of layers doesn't even exist anymore because we've seen the pattern of people just like using layer.scoped to cover their bases. And it's really not harmful to do that because then like the service constructor gets a scope, sure. So anyways, in 4.0, we actually removed the scoped variants and layer.effect, const effect, actually gets a scope by default. Exactly. So folks use layer.scoped as in I might need it layer, but it doesn't hurt. Yes, exactly. Steven, let me finish answering Adam's question before we get too sidetracked, and then we can talk about other stuff. I think we also had RJ chime in with something, and anyway, let me finish this answer to Adam's question and we'll move on. So the real reason why we don't want the scopes that we grab from the environment, the scopes that are being provided to an effect to be closable, is because we could do a lot of unintentional damage to the finalizers of said resources. We could accidentally finalize a resource that's in this scope that is actually being used elsewhere. And then your program attempts to access said resource. You could imagine like there's a database connection being tracked by this scope, and then you close it inadvertently, and now that database connection is gone, and now your app tries to issue a query, and boom, it blows up. So to close the scope on scopes coming in from the environment, it's because we don't want to inadvertently close a scope that's being managed outside the current effect. Now, you can get access to a closable scope in two ways. So a scope that you can manually close. There's two ways. One is by creating a scope yourself. Now you'll notice this is a closable scope. And that's because the program no longer needs a scope. And I think it's literally just scope dot. I think it's scope dot close. Scope. And I need an exit. So by manually creating a scope, we've now, we know where the lifetime of this is being tracked. We're tracking it. We built it in this effect. This scope exists inside this program. There's nothing being passed in through the environment to us. So we can safely give you a closable scope now. Like, you can close this and be confident. I mean, you have to know what you're doing, but if you close that, you can be in control of when this scope is closed because you've created it as part of this program, as opposed to it being propagated through the environment to you. So in theory, what all the things are, what finalizers are going to be attached to said scope. The other way that you can get access to a closable scope, if we go back to our previous example, so we have a type error right now, right? We have a scope here that's not closable. We're trying to close it, but scope is not assignable to closable scope. Let's say we have this situation where we have a scope coming in through the environment, and we want to be able to close some resources associated with that scope for whatever reason, but not close like the parent resources, as in the resources coming in through the environment. We don't want to close any resources being managed here, but we want we want to be able to manually close maybe some resources in the current effect, and we want the closable scope to also be tied to the thing coming in from the environment. So to do that, we can actually fork a child scope off of the parent scope. I think in this case, I do have to specify execution strategy, not sequential. When you fork a scope, you fork a child scope with the specified execution strategy, and the child will be automatically closed when the parent is closed. So if this parent scope is closed, then this child would get closed. But if I manually close this child, the parent is not closed. Right? So we have a closable scope now. Child scope. Oops. We have a child scope that is closable, but the parent is not. And there's this parent-child relationship can be really useful when you want to say have explicit control over some resources that your effect is managing, right? Like maybe this effect, I don't know, after 10 seconds, we want to after a timeout of 10 seconds for whatever program we're building, we want to close some resources associated with that program. But we also want those resources to close if the whole program exits, right? This is a really nice way to do that. You get access to the parent scope, you fork a child off of it, and then the logic in here would be like a timeout and then closing the child scope. And if the parent crashes, all of that cleanup logic would still be tied together. So I guess to summarize this, a scope and a closable scope, the reason why they exist is because if you have a scope being provided to you through the environment, you cannot safely close those resources. You can't safely close that scope to finalize those resources because you don't know what you're finalizing. But if you create your own scope or you fork a child scope, then you actually can safely close the resources because that scope was created within that effect, if that makes sense. Can we see more 4.0 goodies? I don't know what other goodies you want to see. Yes, we can look at more stuff in a second. How code moddable would 3 to 4 be? We have no idea yet. Some stuff will be code moddable, and we will be working on code mods once the beta is out. But we're not sure yet. We're hoping reasonably code moddable, but not 100% sure. I'm
Also,
really excited for...
I think I've seen LLM sort of documents describe. I mean, obviously, it would be the same thing as just a migration doc in general. But I would imagine that even a pretty cheap model would be good at following straightforward refactors. Hopefully.
Yeah, I mean, Julio. It's because schema is changing so drastically in 4.0. Julio's been tracking. Where is it? Packages. Effect. In schema.md here. This document is massive. Details pretty much all the changes that he's made so far. But what's really nice is that at the very bottom,
wow,
the amount of work that Julio's put into schema v4 is actually wild. If we go all the way to the bottom, I don't want to skip it, but usage migration.
Wow.
He's starting to put together some work like this to have migration information for the LLM. But I'd be really curious for somebody who's heavily using v3 schema to feed it this document when they go to migrate and just see how good it does. But yeah, there's tons of information in here. So for anybody who's curious about schema and what Julio's been working on, go read this document. Take an afternoon and read Julio's manifesto on schema v4.
Shall we get to... Oh, sorry.
I just want to answer this last question about v4. I'm really excited for v4. Do you guys have an estimated date range or something? No. When it's ready. We have some stuff in the to-dos. It is the same question every week, but I mean, I get that though. Like, there's excitement. It's taking us a lot longer to pulling the Silk Song move. I see. Yes. Well, I want to answer this correctly. We are really trying to take our time with v4 because we want this to be a long-term stable release. No, Enrico, no. Yeah, exactly. Rather than a yes. I'd rather have a long thought v4 than a v4 followed by a v5 1 year later. That's exactly what we're trying to prevent. We are trying to commit to v4 as a long-term stable release of effect. And so we're trying to get as much as we can right before we release a beta. That said, like, you know, for folks who are just like really chomping at the bit to try out v4, if you go to our GitHub Actions for Effect Small, there's this snapshot tab. And every time we push to main, we publish snapshots. So like if you go to snapshot and click, I don't know, this one, you can, where's the summary? I always like, I can never figure out where I need to go to see the summary. Well, I know I can go into the actual build. And if you go in here under create snapshot, you can see all of the snapshots that we're publishing using package PR new. So you would just do an npm I or pnpm I this to get access to, like, for example, v4 effect. If you wanted to see that, if you wanted to try that out, you could. I wouldn't advise about it because, like, we're still very heavily iterating. But if you just want to kick the tires on a few things, feel free. I always get confused, like, where the check information is. Like, it's supposed to, like, just write a little comment about all of this somewhere. Oh, whatever. If you're interested, you can go to the GitHub Actions and you can install one of the snapshots. And then we have this to-dos. Wouldn't it be in the PR? No, it doesn't publish. We don't publish a comment to the PR with the... Oh, I see what you're saying. Yes. Good call. That is where it is. Yes. Somewhere in here. Checks. Snapshot. No, is it just in checks? Here we go. So if you go to, I guess, the latest PRs, click checks, and then you can see the continuous releases. We have, like, the comments you can use to install these things. And then if you're interested in following, like, the current priorities, it hasn't been updated in a little while because we got pulled off of v4 to work on a few other super high priority things. But I'm circling back to working on this again. And these are the current priorities we have. So Tim's been iterating very heavily on cluster in v4 and in v3, trying to backport as much as he can. But I'll be working on some of this stuff to try to get some of this stuff done, so that we can get into, like, a beta soon, hopefully. But we're not committing to any timeline. I still think we have weeks. Maybe you guys will get v4 for Christmas. I don't know. Let me just make sure I didn't miss any questions. And would you consider it worth it to just YOLO it and use the snapshot releases in prod? Yeah, I wouldn't do that if I were you, but more power to you. if you want to do that. Okay, I think I'm done with questions. Kit, you can take over.
Oh, great. Yeah, I just was going to pull in RJ. So, RJ, I'll accept your call now. Hello. Welcome back.
Hey, guys. Thank you. So I, for folks who were here a couple weeks ago, I guess you're familiar with this, but for those who weren't, working on a library for backend platform called Convex. And I was, the problem I joined office hours to try to solve last time I was here was the problem of trying to replicate the nice APIs that we have in some effect libraries like RPC, AI, HTTP API for composing by means of layers. The implementation is defining a spec for an API, and then creating layers with implementations of that spec, and having the layers track the dependency graph between like the different sections of your API endpoints and stuff like that. So we talked through that a lot last time, and I have a solution based on those conversations. And so I wanted to just thought it might be interesting to show it to folks, and also to get your all's feedback if it turns out that I have made some grave error or otherwise misunderstanding something. So I will share my code editor.
I'm excited. RJ has solved the world.
I've solved it. They said it couldn't be solved. Okay, I have to share my own screen. Sorry, 1 second. Actually, maybe I do this. One moment here. Okay, here we go. All right. I'll make it a little bit bigger. Does this look okay?
Yeah.
Is that too big?
Maybe one tick up, maybe bigger.
Yeah.
Okay. Great. Okay. So here's an example of what, just very quickly, I'll just run through sort of what the API is supposed to look like, does look like right now. And then I'll talk about the implementation. So the idea here is that you create an API composed of groups and functions. Functions are like Lambda functions, basically. So they're sort of like, they're just chunks of executable code. And they're exposed as, they're sort of exposed as like endpoints. You can call them from, a React client or just a generic like, JavaScript client or Rust client or whatever. And so it looks like this. So you can have groups. Groups can contain functions or groups. So you can have this kind of tree here. You construct a group like this. This make function. Then you can add functions to it. So you can see here where we have these different kinds of functions. Queries and mutations interact with the database. And somewhere here we'll have an example of adding a group to a group. So we make the group, we add a group, and so on. And so then down here you have your spec. So this is where you attach all your groups to the like API spec data type structure, and then you implement each of these groups using this builder.group function. You pass in the API you want to implement something for. The group name, you get some nice autocomplete here. So you can select which. Look, I might have in refactoring this messed up some of the types here. Okay, so I'll have to look at that. But anyways, you're supposed to get some nice string autocomplete here for the specific path of the group that you want to implement. And and so this is like the HTTP API APIs. So you get this handlers object, handle method, the function name, args. It's all typed properly, and so on. And so what I was trying to do is figure out how to create this type of this kind of layer, this cool situation where you have like a let's find a layer with some dependencies. So like you have this group BD, and it's supposed to it has a dependency, like it has a group, and you need to implement that. And so I wanted something that looks like this. So you have this produces a layer, which contains a group service for BD, and it needs an implementation, which is a group service for BDE, right? And so the tricky part here was that I was trying to. This is sort of like this nice API is affected by some unsafe code, and I was trying to figure out how to make that happen. So hopefully that's enough. Like,
can I interject
you all
a
recall?
question really quick?
Yeah.
For the groups, the layer they produce and the layers they require, is it required for the groups? So if you hover over a group BD live, for example, is it required in this case that the type that comes out of this be a group, like the group itself, or do these like groups produce? Do the services that this layer produce, is it a set of functions, or does it have to be wrapped up in this API group service? Because with the RPC and the AI and the HTTP implementation, actually I don't know about HTTP, but in the RPC and the AI implementations, it's literally just like a set of handlers for said that are in that group. So I'm just like, I was curious, like, is the group service contain something important here, or could it be that like your types could produce like fixed, like if group BDE, for example, had function 1 and function 2 in it, could the layer that it produces instead produce like function group B, BD, BDE, function 1, group B, BD, BDE, function 2? Do you know what I mean? Like, because for RPC and AI, that's how we do it. We produce, the layer produces a set of handlers. In your case, I guess it would be a set of function handlers, maybe. And that allows you to see, instead of seeing like the group itself that has to be provided, it allows you to see the set of handlers that get provided instead, or that need to be provided.
Yeah. That's interesting. So you're saying...
I don't know if that's the case with the HTTP API. Would have to look back at like what those layers produce. But I know for RPC and AI that's the case.
Right. I don't think that's the way it works for the HTTP API modules, because that was what I was using as the reference here. But let me just make sure I understand your suggestion. So you're saying that like this layer, so let's say I have something like this here, this group implementation for BDE. This would, I guess this only has one function associated with it. But if it had two, I guess, or even if it has one, I guess, it would produce a layer. And instead of this layer being for a group service, it would be like a function handler service, and it would have the path for the group, and then the function's like name or something. And then
I don't know if I don't know if it's possible, but instead of I was mostly curious, but like the for RPC and AI, the layers that are produced, instead of producing like a group of handlers, the layer that's produced it produces the actual union of set of handlers. So if like
Right.
you have like, for example, RPC1, RPC2, RPC3, the layer that's produced is like handler RPC1 union handler RPC2 union handler RPC3. So
Mhm.
in your case, in group BDE live here, you would have like function, and then the name would be like group B dot group BD dot group BDE dot function 5, for example.
Right.
I'm mostly curious on like a technical level. I don't know. I can't recall the way that HTTP API works.
Yeah.
But that's just what we did for RPC and the AI toolkit.
Yeah. Yeah. I'm not sure. That's a good question.
And again,
Yeah.
if this is the way that HTTP API works, there's probably a very good technical reason why Tim did it that way. I don't remember like the details of HTTP API.
Yeah. I would guess based on my expertise so far in building this kind of API that is possible. I don't know if it's worse for some reason for this type of API versus like those in RPC and AI.
Yeah,
Yeah.
we don't have to get too derailed on it. It was mostly a curiosity on my part because I like this kind of stuff. So
No, yeah. No, it's an interesting. I'm just thinking about it. Yeah. Yeah, I don't know. I mean, maybe you'll have more thoughts on it, or more thoughts on it as I like show the implementation, like what my solution to this as well.
Yeah, let's take a look at that. I think.
So okay, so so how does this so how does this work? So I've got it working, I believe. And so what I ended up doing was the call a couple weeks ago when I brought this up, Tim mentioned that there were sort of two different. I don't even actually remember what the other one was, but he mentioned that there were two different strategies that he was aware of for solving this kind of problem. One was a registry strategy, and one was something else. And I don't even know if my strategy is what he would describe as the registry strategy, but what I ended up doing, I think, might be that. So let's actually maybe first look at an implementation of this here, this group function. So so we have this kind of in the builder module, we have this group function, and it takes the API, a path, which is supposed to, you're supposed to get some nice type safe autocomplete here. And then this build function, which is where you define this function where you take the handlers and then you implement them. And then the returned handlers should be fully implemented. And we return a layer with this group service, which provides this group service and has dependencies on the groups that group depends on. So in the case of like BD live, it requires BDE live. If we look up at the spec definition here, we see that BD has this BDE group, right? And so we have this we have this layer which has the right dependencies here. One thing to note is that this group service is different from API group. API group is what's produced by, it's sort of like the spec, right? So that's what's produced by these functions, this make function here. And group service, it doesn't really actually even matter what it is. So it just looks like this. It just has the API name and the group path in it. That's it. And these are injected in the like identifier for the service.
Makes sense.
And so we do this, and then within this group function here, we use this registry service, which looks like this. This registry service is it's like a nothing service. It just contains a record, and just updates this record. So this record has so this record has keys, which are the function paths. So this would be like group A, whatever, something like that, right? Or if it's more nested, it's like that, and just as a string. And then the handler item, which is the implementation for that function. So it's just a mapping of path to handler implementation. And so we go through and we have this. We return this layer, which it gets the registry service, and it gets the handler, the correct handler, and gets the path, and then it just adds it to the registry, and then we say, screw your type safety.
Do we want to finish going through the full vertical stack before like going off on little tangents or like little nitpicks or tips, or do you want to do breadth first, or?
I want to see how you wire it to the file system structure that convex expects.
Oh yeah,
I remember because I remember that was the sticking point that we had the last time. Was like, okay, how are you going to take this and convert it into like whatever convex expects for their API?
Yeah. Okay, well let me try to finish, I guess. This is mostly it, but I guess I'll just sort of like try to wrap up this piece here, and then we can talk about that. That sounds good. Okay, and I can't see you guys, just so you know. So I've only got my one monitor here, but I'm assuming that sounds good.
No worries.
Hearing no objections.
No worries. That's good with us.
Cool. Okay, so I guess the insight here, is just that like this is the only insight, but like this is kind of fake, right? Like what you're returning here is not actually what is being returned, and there's this dependency on registry, which is not represented here in this layer signature. And so it's this sort of like shadow dependency or something. I don't know. And so what happens is when it comes to actually getting the layer that contains the Confect API service, where basically the idea is that you should only be able to get this layer that returns the service with no dependencies once you have satisfied all of the requirements of this API, meaning like you've implemented all the functions.
Right.
So once you do that, or to do that, you call this API function, and then you provide the implementations for the top level groups, which should themselves have had their implementations satisfied, the dependencies satisfied. And then we do some stuff here. We map the content. So I'll be honest, I don't understand this as deeply as I'm sure I could. I sort of got sufficient understanding of what was going on, I think, to be able to solve the problem. But again, this is based on Tim's code, so feel free to fill in any gaps or again correct me. But we create this Confect API service, and we do so by taking the. Let's actually look at that first. So that looks like this. We have the API. We have the API. So this is this is like the spec, and then Yeah, and then, well, it's not the spec. It's the spec with the implementations. Is that right, actually? Let me see. API, no, right. So, right, this is the spec. Yeah, the implementations are in the context. This is the spec,
Yeah,
basically. We also,
your handlers are coming back in the context. You have your spec that you're
yeah,
attaching. You're basically co-locating the spec with the implementations here.
right, exactly. Yeah. And then, yes. So, yeah, so we do that. And then when it comes time to actually like using this, so we have these things all together now, and now I guess to your question, Maxwell, how do we then hook this up to what Convex expects? Because Convex actually expects to read these functions and deploy them. In order to deploy them, read them from the file system. And it actually, if you have like, I don't know, say you have a function at, say you have your convex folder. The way it usually works is you have your convex folder, and then you have, my dir, my func, and this would be the path for this would be my dir.myfunc. And or if this is a file, actually, maybe this would be like my dir, my mod, my func. So you'd have like inside of this, you'd have you export
Right.
a function, right?
Right. Mm-hmm.
Yeah. And so first of all, we need to get a data structure that we can use to like to somehow get to this point, right? And so then here we take in this API service layer, and we get the API, so it's like the spec, right? We use the registry here to get out all of the paths and their implementations, and then we've got what we want. We've got what we want in the same place, and then so we need to provide the API service layer to this effect here, and then I also provide merge an implementation for the registry here to this layer. So that's how we bundle all that up. Okay, yeah. So I guess just pause for a sec. That seems to work. Seems to solve the problem. Any concerns, thoughts, feedback? I would be open to.
Where's the thing that's actually writing this to the file system, or do you literally just call the API?
So I haven't done that yet, but I'll talk through how I plan on doing it. I've thought about this for a long time because this seems really annoying, right? Or to me at least. So I don't know. Like I'm going to look a little bit more into whether or not I can just like, there's like, I mean, there are obviously APIs that Convex uses to deploy these functions, and Convex also like, they like bundle them and stuff. And so, I may look into that a little bit more. It seems like trying to hook in at that layer seems probably more fraught and certainly not intended. So I'm a little wary of that. So what I would really prefer to do then is to somehow take these implementation, because these end up so what I do here is I go through this record, I map all the values, and I turn them into registered functions. And these are the things that Convex actually expects to be exported from, like in this case, right, from like a module in the Convex directory. And
I guess like what I think is going to be difficult, just from like looking at this, is right now you don't actually have the physical code for the handlers. Do you know what I mean? Like if Convex is expecting, I don't know like what the plan is going to be necessarily, and I'm sure you've thought through this, but like one of the things that I see being potentially difficult unless you're planning on using this server thingy directly, in the different like folders and files, whatever, is that the convex, the way I understand it, expects like the actual code to be in this folder structure, and right now these
Right.
handlers are just in memory pieces of code. So
Right.
probably you'd have to like write the code gen you'd be writing would like dump the server dot path or something like that into those
Yeah.
files, and that would be what would be bundled.
Yeah.
Anyway, when you get there, it'll be really interesting.
Yeah.
I think this is fun. This is definitely fine. I could see a few ways, like effecty ways, that you could like improve some of this stuff.
Hmm.
But that like, I think that'll be like the biggest challenge. I think, especially, and also wiring together the convex like dev stuff with this code gen,
Mhm.
because like anytime you keep layering code gen on top, it gets like more tricky.
Yeah, definitely.
But
Yeah.
like one effecty way I could see like to circle back to more effect office hours-y type of stuff, because I know that some folks who may have not watched previous office hours may not have all the context on like the type of API that's being designed here. One like effect-ish example we could look at here is your the API registry.
Mhm.
Since you're always using the same implementation here,
Mhm.
and in theory, like pretty much everything you're doing in there is synchronous. Like
Mhm.
if we go to the API registry service, you could, instead of making this an effect.service,
Mhm.
you could rewrite everything in here to be synchronous, and use a context.reference instead. So a context reference. So if you import the context module, if you from effect, and just type like context.reference. So context references are interesting because they allow you to create a tag that can also hold a default value for the service. So
Mhm.
you actually never have to provide the service in this case.
Mhm.
You can just yield the context reference tag, and if you never provide it, the default value would be used.
Hmm.
So here, what you could do is you could create a default version of this service, like even just a class that uses that's the default value, right? Because all you're doing here is shoving stuff into a object,
Right.
and then you don't have to worry in the, I forget which service it was. I think it was in the groups or somewhere where you're yielding inside the layer and you're sort of faking the types.
Yeah. Mhm.
You wouldn't have to fake the types anymore, I don't think, because the yielding a context.reference adds nothing to the effect context.
Mhm.
So it's a way of creating a service that knows that it has a default implementation. The difference with context references is that the default implementation has to be synchronous, and it can't depend on other services.
Yeah.
So yeah, you could literally like refactor this service to be just a simple class that shoves stuff into a map in a closure,
Mhm.
and uses context.reference. And then in your API server where you provide the default implementation here, you could literally remove that.
Mhm.
And then in your like group layers, when you yield the reference, it would just, the first time you yield it, it would get the default value, and then every other time you wouldn't have to like right here where you
Right.
yield the registry service. The first time you do this, it would, if you haven't provided one, it would use the default value, and then that would get cached. So every other time a group gets called, it's just using the same default value service. So
I see.
yeah, so that's like one thing I could see.
Huh.
Also in here, a small optimization you could make is since for each is not doing any concurrent work, you could just use a simple for loop
Mhm.
inside the generator. And again, like if you switch this to a context reference, I'm fairly certain you could remove the as any on the layer.
That's interesting. Yeah.
And
Yeah,
this
yeah.
only works because like the API registry service in this case is literally just like synchronously appending to a map.
Right,
So
right.
the ref is really superfluous and like and it's like not really doing anything in this case.
Yeah.
Like the use cases in effect that I see for ref is when you need to pass the ref around to a bunch of different places. But if
Mhm.
you're just using it within a service, like
Yeah.
sometimes it's more superfluous than not. So anyways, this could be like a interesting way to, make that small improvement to the
Yeah.
group service.
That's
Yeah,
great.
a
But I
ref is
talked a
also
lot.
useful if like you're sharing an immutable value that you can't modify otherwise, or have a variable pointer to, like a number or something.
Yeah, this didn't feel like it should be necessary, so that
Yeah.
that makes sense. Yeah.
Yeah, I doubt
Um,
anyone comes from Scala, but like, obviously Effect came from the Zia library and Scala originally, and they have a ref. And in Scala, you do have concurrent programming, you have parallelism. And so a ref is really important when sharing mutable data to manage that and not have it overwrite. But in TypeScript and JavaScript, it's not so necessary, but it still has use, but not for concurrency safety. I was confused at first. I doubt many people have my experience into Effect and TypeScript, but if you did come from another language, that's good to know.
Cool. If you all have a few more minutes, I would love to share my thoughts on how I was going to go about this, and get y'all's thoughts on whether I'm missing something based on your understanding of the situation. And I can't see you. If that's too much, then that's totally fine as well.
I was going to say that I'm happy to give thoughts, but I'm not sure they'll be useful at this point because I think the only way you'll know if what you've got is something is if you try it and it works.
Yeah.
I can't tell you if it's going to work.
Yeah,
But go ahead, kid. Sorry.
I think so. Did you happen to see the last session, RJ, or was it Tuesday? I think last session I kind of walked
No, I
through.
actually didn't. Unfortunately, I was traveling.
No.
And again, but
Priorities, RJ. Priorities.
Shame.
Yeah, I know. It should be effect number one. Everything else last. Agreed. Forgive me.
But no, it's okay. Well, it's on YouTube, but you don't have to watch it. But I kind of walked through something similar. I was curious, as I mentioned, how the HTTP API and RPC API thing worked. So I sort of quickly walked through sort of a series of evolutions towards something like that, where you provide the implementations via a layer. It doesn't do everything your thing does. The one thing I tried to suggest there, and I may have mentioned this to some degree, but like starting at the bottom, like with that example, I sort of start from basically just a hard-coded implementation. There is no abstraction. It's just sort of an inline HTTP server, a very stripped down version, right? Where it just matches on everything and there's a set of if statements and it like returns the raw response. And doing that first, like for this, I mean, you don't have to do the whole thing like that, but like just, it's really could be helpful to get an idea of just, at the very end, how would you even get convex to call? Like what kind of code do you need to generate, to get convex to call it? But I'm really curious. You should definitely call in again when that part's done. Very curious to see what happens.
Cool.
Besides that, I don't have any like critiques. This looks pretty great.
I love I love the API. I actually did experiment with confect a little bit.
Cool. Doesn't have this feature right now. Right.
Yeah. And I just like kept thinking about all of the stuff that you're working on, so I'm like definitely very interested in trying this out. But I agree with Kit. Like we could look at this, but I'm not well versed enough in convex to know if what will happen will work. My intuition tells me that like maybe exporting the handler will be enough, but I don't know. So I would say like the next time, definitely call in again and we can look.
Cool.
But I love the API. If that means anything to you, I would love
to use
this.
No, that's great. That does mean a lot. Definitely. Yeah, absolutely. I'm really glad. I've been working on this on and off for like 2 years. So I've had a lot of time to reflect on some of the sort of APIs that I want here, and I'm trying to strike some kind of balance between what an effect user is familiar with, and just get the benefits, obviously, of many of the nice API patterns in effect, and marry that with how Convex works. And so, anyways, I'm glad. I don't know who I'm trying to target more. Somebody who's used Convex and wants to get into Effect, or has used Effect and wants to get into Convex. But it's at least good to hear that the Effect folks like how it looks. That's definitely nice.
And you'd be able to call these on the front end as well, like as a
So the idea. Yeah, the way it works is, with Convex right now is you get like a type safe React client generated, just sort of like it's generated unlike. Yeah, it's without going into too much detail. It's generated instead of derived manually in the way that like the HTTP API client is, or the RPC client is. But I'll be able to. You'll be able to do the same thing you can with the RPC or HTTP API modules. You'll be able to drive a client and then call all of these directly from the front end, which is something you can already do with Convex. What this will allow you to do is this will allow you to get the rich schema encoding and decoding as you call it. So you can provide you can require that that foo is a branded string, for example, or that it returns a branded string or something, or something more complex, and it'll be encoded into the JSON serializable, format that you define. And then sent across the wire, and then when it comes back, it'll be decoded according to whatever your return schema here is.
Super cool. I like it.
Yeah,
I like the
API.
nice. I want to use it.
Great.
Yeah, all right. Convex. It seems very cool. Is there like one quick thing, like a pitch for Convex? Like, is there a kind of application where it is most fitting?
I think that it is a great fit for the vast majority of applications. I think so. What's really cool. My pitch for Convex. It's really cool. Well, there are a lot of really cool things about Convex. Confect is probably the number one, especially this version once it gets released. But other than that, or maybe I should say Effect through Confect. That's the coolest part about Convex. But it's got it's fully reactive. So so if you're using React, if you're just using the normal React Convex client, you get access to like a use query hook, and you pass in a reference to the function that you want to call, the query that you want to call. And this query will update reactively. The value returned from that hook will update reactively if the query would change, right? So if any of the dependencies of that query change, and it'll also do so atomically. So if you have multiple queries, you'll always get a consistent view of your data through the client, and I think that's the neatest part about Convex. And I think most applications benefit from that. It makes it really easy to implement a lot of things, and in my experience, that's been sort of like the worst part of it. It allows you to treat the backend a little bit less. The backend and front end a little bit less like a distributed system, which is really nice. So
cool.
Yeah.
Very nice.
Well, thank you, RJ. I think this is great. And definitely, if anyone else has a project like this, I think this is like one of the best uses of office hours, just because we could look at something that's written in effect and talk about things in context, which, and this will sort of spark many different rabbit holes we can go down that I think will be more practical than just some other things. But yeah, thanks, RJ. Really appreciate it.
Cool. Yeah. Thank you guys. Appreciate the help and feedback. And I'll come back when I have some more. And hopefully soon with the release. It'll be even better.
Oh, Benjamin wants to know your Discord handle if you're not anonymous on there.
I'm not. This is my Discord, I guess, name, but I'm on there. My username is just displayed as just RJ. But yeah, feel free to shoot me a message if you've got any thoughts or anything.
Cool. Well, thank you, RJ, and I guess thanks everybody else. We've been going for an hour and 50 minutes, so probably a good time to call it a day. But yeah, see y'all next week.
Cheers, everybody. Thanks, RJ.
Take care.
Peace.
Bye.